Welcome to Sarah Science, where impossible questions become real science. Now imagine this. You're standing on the ground. Everything feels completely normal. Then, without warning, gravity suddenly stops. No explosion, no earthquake, no warning. Gravity simply becomes zero. What happens to you? And more importantly, what happens to Earth? Let's find out. The first thing you'd notice is surprisingly simple. You would start floating. Right now, gravity is constantly pulling you toward the center of Earth. It's the reason your feet stay on the ground. It's the reason your coffee stays in your cup. And it's the reason the atmosphere stays around the planet. Remove gravity, and suddenly, nothing is being pulled downward anymore. If you're standing still when gravity disappears, you wouldn't instantly shoot into space. You would simply become weightless. The floor would still be underneath you, but the moment you jump, you wouldn't come back down. You'd keep moving upward. And if you're inside a building, the ceiling would quickly become your new problem. But you aren't the only thing floating. Your phone, your furniture, your pets, your water, everything that isn't physically attached to something would begin drifting. Even the air around you would start behaving very differently, because Earth's atmosphere is held close to the planet by gravity. Without gravity, the atmosphere would no longer have anything keeping it attached to Earth. It wouldn't disappear instantly, but gases would begin expanding outward into space. And that creates an even bigger problem. You need air to survive. As the atmosphere begins escaping, the pressure around you would fall. Breathing would become increasingly difficult. But here's where things become truly terrifying. Gravity isn't only responsible for keeping you on the ground. It holds the entire Earth together. The planet you're standing on is a giant ball of rock, held together partly by its own gravity. Without gravity, Earth wouldn't instantly explode like a bomb. But the forces keeping everything together would begin changing dramatically. The oceans would no longer be pulled toward Earth's surface. Massive amounts of water would begin lifting away from the planet. The familiar shape of Earth's oceans would disappear, and the same thing would happen to lakes, rivers, and eventually enormous amounts of surface material. But there is an even bigger consequence. The moon. The moon stays around Earth because Earth's gravity constantly pulls on it. Without Earth's gravitational pull, the moon would no longer follow its normal orbit. It would continue moving in the direction it was already traveling, essentially flying away along a new path through space. And Earth itself would no longer be orbiting the sun in exactly the same way. The sun's gravity is what keeps Earth traveling around it. Remove that gravitational influence, and Earth would stop following its curved orbital path. Instead, it would continue moving roughly in a straight line through space. So now imagine looking up. The sun would still be shining. The stars would still be there. But Earth would no longer be following the path that has kept it in the solar system for billions of years. And there is another strange consequence. You wouldn't feel gravity disappear as a force pushing you away. You would feel weightlessness. That's because weight is the force gravity normally applies to you. Your body would suddenly behave like an astronaut's body in space. Your blood and other fluids would shift. Your muscles would no longer need to fight gravity to keep you upright. And if the event lasted long enough, your body would begin experiencing the effects of prolonged weightlessness. But suppose gravity only disappears for a few seconds. Would everything be destroyed? Not necessarily. And this is where the scenario gets interesting. If gravity returned quickly, many things could eventually fall back toward Earth. But they wouldn't necessarily return to exactly the same place. During those few seconds, everything that was floating would have continued moving. Water would have moved. Air would have expanded. People would have drifted. The moon would have changed its trajectory. And Earth would have traveled slightly away from its normal orbital path. The longer gravity remained gone, the more extreme the consequences would become. Seconds could create chaos. Minutes could create a catastrophe. and a much longer disappearance could completely transform Earth. But there's one more important detail. Gravity doesn't work like an invisible switch that can simply be turned off in reality. According to Einstein's theory of general relativity, gravity is connected to the curvature of space-time. So, a sudden magical disappearance of gravity isn't something modern physics says you can simply make happen. That's exactly what makes this thought experiment so fascinating. You're taking one of the most fundamental forces in the universe and asking, what if it suddenly wasn't there? And the answer is terrifying. You wouldn't just lose the ability to stand. You would lose the invisible force controlling oceans, atmosphere, moons, planets, and even the paths of entire worlds. Gravity feels ordinary because you experience it every second. You don't notice it holding your feet down. You don't notice it keeping the atmosphere around you. You don't notice it guiding Earth around the sun. But remove it, and you suddenly realize something incredible. Gravity isn't just what keeps you on the ground. It's one of the reasons Earth exists, in the form you know. So the next time you jump, remember this. You're not simply coming back down, because the ground is underneath you. You're being pulled back by an invisible force reaching across the planet. And without it, your world would become something completely different. If this thought experiment made you look at gravity differently, like this video, and if you want more impossible questions explained with real science, subscribe to Sarah Science. Then comment below, how many seconds do you think humans could survive without gravity? Your answer might be very different from what you expect. Until the next impossible question, keep looking at the universe differently.